Okay, here we're in R, and we're going to look at the Wilcoxon sign rank distribution. And in our example, we created this grid, which represents, the data were all from a negative value. Here, the data were from a positive, a negative, a negative. So these are the WJs, and you do that with the expand grid function. And then we need to take the rank, so this is rank 1 times each of those, rank 2 times each of those, rank 3. And that's what this step does. So here, wherever there was a 1, there's now a 2. And over here, wherever there was a 1, there's a 3. And 1 get multiplied together. Now we need to add the rows, the row sums. And so that's what this next step does. So if we add straight across, then these are the numbers we get, and let's put those in a table. And this is exactly the table that we got on paper. And let's do a proportion. So this is the density of the test statistic when n equals 3. Now, to do this in general, I create a little function here called the sign rank. Now, this function is very, very inefficient, and you should not use it for large n. 20, 30 would probably be the max. R has a built-in function that is much more efficient, and I'll show you that in a minute. But I use this for illustrative purposes. So when we have 4, and this creates the grid like we did here, and then multiplies it times the rank, and then calculates the probability. So this is it. So this is for n equals 4, the probability. So this is 1/16th, 1/16th, and 2/16th. And now when we have this density for our test statistic, we can calculate probabilities of being, say, greater than 10 or equal to 10, and that's 0.06. And so we can start developing tests. And then when it's 5 and 6 and 7, etc. So here is a plot of our distribution when n equals 4. But let's do it for 15 and see what it looks like. This is the plot for 15, and now the tail areas start get pretty small. So to be above a certain value, this may be 0.05 right here. So you pick the value that makes that true. But you really do this with the built-in function in R, and that's called the D sign rank. So that's the density of the sign rank. And so let's look at it for 4, which we did just a second ago. So when you plug in 0, when n is 4, you get the 0.0625, and that's what we get from my silly inefficient function. And then let's do it for 4. When n is 4, what's probability that we get a 4 from our test statistic? Well, it's 0.125. It's the same value. And we can do a sequence from 1 to the largest sum we would get, which is n times n plus 1 over 2, and using the built-in function, and we get the same values that we got doing it the silly way, but for illustrative purposes. Now let's do it for 40 and see how fast it is. That is instant. Almost when I touch the button, it calculates that. And if you do that using the function I created for illustrative purposes, it's going to take several seconds, maybe several minutes. And let's look at a plot of n equals 40 of the sign rank distribution. And this is it. It's very normal-like. Well, that's all I have for today to keep the video short. I hope you liked it. If you did, please like it and subscribe so you don't miss the next one. Thank you. Bye.